Good morning. Thank you for coming. I am Paul Vixie. I work for AWS Security. Our mission at AWS Security is to secure the infrastructure of AWS and the customer workloads. Those words never change, but what those words mean tends to change every few months because the infrastructure contains new kinds of things. The workloads have different kinds of risks, so we adapt. And since we have been adapting to AI in recent years, I was asked to say a few words about what that has entailed and what it may have taught us. And ideally, some of these lessons will be portable to your own conditions. So, when I encounter new technology as a security professional, I usually have three questions. The first is, how can this be used by attackers? What will I see? What will be different? How will the attackers' engineering economics change once they have this technology? Second question is, how can I use this new technology to defend? In other words, I've got various problems I'm trying to prevent at scale. Usually these problems involve an adversary. Is this new technology applicable to those problems? And the third thing will be the technology itself. What new risks will it create? How do I secure the technology? And you can look back through time. Any time an information technologist for a network of any size adds a new service, they do have to wonder, how secure is this service? How will it be attacked? How will I be attacked now that this service is in the world? For the case of trust, we have one more question, a fourth question beyond those related to security. And that is, how can I believe what it's doing? How can I verify? How can I monitor? And you'll see that this question was very much operable across time. See if I have a slide. Oh, there we go. So when we first added, the web to our internet stuff, we all started putting browsers onto our desktops and the desktops of our users and customers. And those browsers gave them fantastic new possibilities. And some people are overly trusting. They'll just believe that everything they're doing will remain secure even though they're doing it in a new way. And in the early days, when we did not yet have encryption for the web, that meant that people were putting credit card numbers and passwords into web forms because they naturally assumed that this new technology would be trustworthy. Turned out not to be so, and it turned out that that was a holdup. In other words, we were not going to get universal deployment of web technologies until the web traffic itself was encrypted. And that is when it actually became safe to send sensitive information over our web browsers. So we would have remained a very small web community if we had remained unencrypted. That's an odd example of adding security to a system which already exists. Normally, you can't fix a system. You can't make it secure by adding layers. In this case, we added a layer of encrypting our traffic. Normally, if you don't think about security from the first moment of your design, you will have to have a different design. You'll be tearing it apart and starting over again. One of my colleagues in the Internet Engineering Task Force warned us at some point that security is not magic pixie dust that you sprinkle over a protocol after you think it's done. Security has to be in your mind the whole time. So we have two examples here, which I think are grounding. Let's imagine that you are a doctor and you have a portable X-ray machine and you are out in the hinterlands where the patients are, and you've taken an X-ray, and you are not an X-ray technician. You are not a radiologist, you're a doctor. And that means you will not trust your own read of the resulting X-ray. You need it to be seen by an expert. But it turns out there is a internet connection, and you can upload that X-ray to a place where there are radiologists, and in particular where there is AI assistance for those radiologists in order to help them learn whether they're reading it correctly, be sort of an extra set of eyes. But you as the doctor might hesitate to press the transmit button because you're not sure that the place it's going understands the patients you have. If there is an AI model, you don't know if it's been trained on the type of people who live on the continent where you're standing. You don't know who else will be able to see this image or see the results. And if, as a doctor, you're trying to make sure that you do no harm, your finger may hover over the transmit button while you're trying to decide, should I trust this thing? So, inevitably, you should trust that thing, but first you should verify. So let's look at the other example, and this is Pinterest. They are a social media company. They have a lot of customers. They have a lot of traffic, and they were adding AI to their recommendation engine. And they had a related but different problem to that doctor with the X-ray machine. They could not have a human in the loop. This was not going to be an AI engine that would help humans who were going to see every recommendation, because there were 10 million such recommendations coming through the system every second. There cannot be enough humans to be in that loop. So in their case, they engineered trust into their design from the earliest moment. And the examples I'm giving here is that they wanted responsible AI practices in terms of protecting the privacy of their users from third parties. And those third parties might include your syslog. And I mentioned syslog on the stage the other day. You do need a record of what the system has done so that if you're trying to diagnose a problem, you can see the record and you can say, well, this is what happened, this is what the data was. But in the case where that data can include personally identifiable information, you probably have a lot of reasons not to make that log file generally available. Could be a regulator, or it could just be good business practice. So that's part of responsible AI, is do you keep enough information to diagnose? Do you anonymize that as much as possible? And do you protect it even after it has been anonymized? And they did, because they knew those issues. If there are some content moderation policies, someone asked for a recommendation of something that you do not want your Pinterest to be on the record as having recommended, possibly criminal activity, you need to be able to stop that. And again, you'll be trying to stop that with the automation itself. You can't ask a human to look at 10 million recommendations a second. But they did all of those things. And the result, happily, of Pinterest adding AI to its recommendation engine was 17% revenue growth in the first 12 months following that launch. So they were happy, and we are proud of their success. Why are these cases different? Certainly the doctor did not build the X-ray machine or the AI that will read it or the internet that will carry it, and so the doctor was never going to have reason for confidence in all of that if the reason had to be grounded in her own experience. Rather, she had to be aware generally of the issues and aware generally of which issues had been solved and which ones had not been solved. And again, ultimately, we must find a way to trust. But sometimes that involves back pressure before you can trust, and that back pressure can take the form of slow adoption of new technology that could otherwise save money, save lives. So this means that, as I said, trust has a fourth way of looking at it. So if it's a security issue, it's those first three things I talked about. But if it's a trust issue, it becomes the whole question of why and how do I trust this? And I think we've all been observers of the great large language model and chatbot rollout in the last few years, and there have been some high-profile stories of what were called hallucinations, or someone uploading more information into the chatbot than they should have because they didn't know it would be shared with the rest of the free tier. And what we need to do is get to the point where we're sure that nothing like that remains in the system. Or if it does, then it's already being worked on and we know what it is. And I think that general adoption, universal adoption of AI will certainly come. But this will be one of the enablers of that adoption. What I like to tell people about security, since I am a security professional, that means I am literally paid to think bad thoughts. What I like to say is that if your application, your business, your workflow could be analogized to a very powerful sports car, and you were driving that sports car on a twisty mountain road at night, no street lights, just you, the car, and a twisty road, and you don't know what else. It'll turn out under those conditions that the engine, the number of horsepower, how powerful the car is not going to dictate your top speed. You will not be able to use all of your engine under those conditions. But you can get more of your engine applied to your task if you have excellent headlights, and you have excellent steering, and you have excellent brakes. Because if you can witness changes to your own operating conditions as they are about to happen, and if you could change your mind about how fast you were going or which direction you were going, without worrying that there would be some failure that would send you off the road into you don't know what, you'll go faster. And we in security are in the headlights business and the brakes business and the steering business. It's not to say that we don't really enjoy high-powered cars, but again, we're trying to use the power we have as efficiently and as completely as possible. And all of this is also true of trust. If you don't trust that car, if you haven't verified the condition of the brakes, for example, then you won't depend on them. You will drive slowly. You will get where you're going eventually, but you could have done better if you had trust. And trust should not be extended arbitrarily. It's not a gift, it's earned. And with AI, we're still sort of in the process. We as a community are still in the process of learning to trust, learning how to trust, when to trust, why to trust. So I mentioned earlier that when we added security to the web, it made it possible to use the web for everything. And indeed, that has reshaped the global economy. I think that the velocity of value that flows through the world economy is much higher now than it would have been without the web. And that this could only happen if we had figured out how to trust it. Figuring out how to trust is sometimes trepidatious work. In other words, if you are using the web and encryption has not been added to it yet, you may trust inappropriately and have your credit card number observed by a third party and then used to make charges on your account. So the early adopters should be rewarded. We owe them a great deal for helping us spot the troubles. But it's happened before. When the telegraph first came into the world in the 1800s, it was not generally trustworthy on its first day or even in its first year, because you didn't know if your message was going to be reliably delivered. That means it not only gets there, but it hasn't been tampered with. You're not sure whether a permanent record of your message will be kept by the telegraph company, and if so, who will have access to it. There was a lot we didn't know. And some of what you learned when you learned was disturbing. For example, there are a whole bunch of individual operators at relay stations who would have to witness your unencrypted message because they'd be receiving it from one link and retransmitting it on another. And that did not mean we didn't trust it. We learned how to trust it, we learned when to trust it, and we learned how to make sure that what we were sending was not so sensitive that having it observed by human operators would be a problem for us. In other words, we changed what we intended to say and how we said it based on our confidence level in the secrecy and reliability of the system. And that's important because that will almost always happen. We will almost always be offered some new thing that will in turn offer some new risk. And it pays all of us in this room, anyone in the security profession, and probably anyone in the information profession, to learn that, learn the limitations, learn how it should be used, learn how it should not be used. Not only so that we can use it appropriately ourselves, but so that the people who depend on us for IT and security expertise can be guided towards safe use of the new technology. My entree to this world was spam. In the 1990s, when we first began commercializing and privatizing the internet, we had suddenly 10 million users that were out of the general population instead of 10,000 users who were all academics and government contractors. And so the system that was designed for that small network assumed trust. It assumed that everyone who could reach you by email was trustworthy. That turns out not to have been true. I'm sure those in this room have all received email that they did not solicit and wish they had not received and don't know how to make it stop. For me, a lot of it comes from my political party, but there's also just a lot of random junk because we are using technology that assumed trust in a network that lacks trust. So my contribution was the distributed reputation system. And that was where you could keep a record of the IP addresses that had been used to transmit spam and make that record generally available for policy purposes. This is all well known now, but we were the first to do that. And it was a big shock to all of us. I, in particular, was the target of a number of lawsuits by companies who wanted to send spam, and they didn't understand how I was stopping them. That was an expensive way to learn that lesson, but it was only after the spam problem had been not solved but settled with that we began to depend on email for anything serious. I think right now we all expect to get email containing a 6-digit code when we are logging in from a new place to some company where their website has an account for us. But if we're coming from a new place, they want us to verify our identity, and they use email to do that. They send us a 6-digit code in clear text, unencrypted email that anyone along the path could potentially keep a copy of, but they don't. For whatever reason, the system has evolved to the point where that is a reasonable assumption, but it had huge cost-to-benefit analysis behind it before it could become the norm, and it would not have become the norm during the absolute hurricane of spam that was happening at around the year 1998. So yes, we learned how and when to trust email by initially trusting it too much, having some high costs, and then adjusting. Now we are adding AI, and we are in that early stage where we're learning how to trust it and when to trust it and how to make it more trustworthy, both as a consumer, which means how we use it, and as a producer, which means how we build it. Now at AWS, we are in the business of helping people build services for the world that are accessible mostly over the web or over the internet. And so we have made some investments in AI technologies. I won't be speaking too much about those today, but we've also made the corresponding investments in learning how to make it more trustworthy and how to trust it and when to trust it. And it is those lessons I intend to share with you today. So, starting with these chatbots, I guess they look primitive by today's standards because it's been several years since they came out. Things change quickly. But they were stochastic parrots. They were word predictors. They could be trained on a corpus of information so that if you asked them a question, they could answer with the statistically likely words from their training corpus. And it was surprisingly effective, although it had some hallucination problems. Then we got generative assistants. In other words, I'm writing a document, I'm writing a PowerPoint, I'm writing computer software, and I need acceleration. I need help. I need an assistant at my side who can help fill in the parts that don't require as much creativity. And that's been very successful, but it still had humans in the loop, right? It was an accelerator to some human who had that job. Now we're moving into the agentic era where we won't have a human in loop most of the time because the human will be asleep or will be doing other tasks. And so the agent is unsupervised and they have some powers. They are able to act on our behalf in various ways. And we're still learning exactly how to trust that. I watched OpenClaw, for example, come into the world, and we almost immediately saw that a leader in a California technology company had given OpenClaw access to her email, and it had decided that the right next step was to delete everything in her inbox. I'm not sure how that logic error occurred, but it was a difficult way to learn the lesson that you need to learn to trust before you extend trust. Trust is earned. So there are a whole bunch of different things that have to be true in order for the trustworthiness of your AI to matter. So in our network, everything is encrypted, right? It's probably encrypted by the customer's own application, but then when they submit it to the cloud, we encrypt it again with an end-to-end encryption layer, and then we hand it to our network, who encrypts it again every time it enters a new link in the path. So there's a lot of encryption, and that means there's no benefit at all to passively collecting any traffic on our network. It will have between 1 and 4 layers of encryption, most of which are impossible to break using current technology. And even with the post-quantum, it tends to be the control packets rather than the payload packets that are being protected there. Because if you can capture the control packets, you might be able to decrypt the other. But in any case, we also sort of need to figure out, you're sending your data to a model, you're writing an application that depends on AI, and you want the benefit of this fuzzy logic that can evaluate your work and give you something back that will maybe be a summary, or maybe a potential conclusion, or maybe a potential answer to an inquiry. It's vital for me as a user of AI to know that the model provider is not able to use my questions as part of their training data. I understand training data has to come from somewhere. I just don't want it to come from me, because my workloads are sensitive to me, and I really want to make sure that nothing leaks. So at AWS, we developed something called Bedrock, which is a sort of a universal AI API, so that you can choose which model you want to use, but then use the exact same API when talking to it as you would if it was some other model. We also containerize the models that you can reach with Bedrock. So if you're concerned that the model provider can see your text, that concern evaporates in the presence of Bedrock. Now, most people don't need to think about this, but as the builder of these systems, we had to think about them, because we want to remove these risks from consideration. We want to accelerate the time when it becomes generally possible to trust the new technology, and it therefore becomes ubiquitous. We have also added guardrails, and generally a guardrail is meant to look for questions that should not be answered. Again, questions about how to build a bomb or some other illegal activity could potentially be answerable by the model. It might know something, it might say something. We don't want that to happen, and so we developed guardrails, not so much so that we could have policies about what should not be accepted as a question, but so that you, as the builder, could establish guardrails around what questions you did not want answered. Then we added automated reasoning checks so that we could also look at the answer. And it's work to describe in formal mathematical logic a system of constraints that will tell the system at query time or at response time that this answer does not match reality. This answer is too far away from the truth, and we can tell. And so we want the model to reconsider that and find a different answer. So the automated reasoning checks that we added to our guardrails were a solution that relied mostly on mature technology we were using for other things. If you've heard of CEDAR, then you know that we have automated reasoning as a method of externalizing the authorization process for your applications. This is mostly that team using mostly the same logic. And once you can establish some good approximation of what questions should not be answered and what answers should not be used, you can have more trust. and you know when to trust. And it is that confidence interval around knowing when to trust and how much to trust that then gives you the headlights and the brakes and the steering that you need to get the power out of this engine. And that's the role of security and of trust in the AI revolution that we are all now living through. Recently, we announced the AWS Security Agent because as security professionals, it is always the goal to achieve greater scale through better automation. Right? It's possible that a penetration testing team from 10, 15 years ago was doing a very good job. However, the number of things which must be pen tested has skyrocketed since that time. The number of new systems, both by us and our builders, our customer builders, the number of revisions to those systems, enhancements, new features, has climbed steadily. And having the agility to bring things to market quickly and to have them be relatively well secured so that you understand how and when to trust them on the first day is huge. That agility is almost the first term of the expression of business success. And so relying on humans might have been reliable enough, but hiring an extra 1 million humans so that you can keep up with the agility of the businesses, not just the cloud itself, but the cloud's customer builders, was not possible. And one of the reasons is people are using agentic AI as coding assistants, so they get more code faster. And that code is generally not more or less secure than the code that was written by humans previously. So we didn't change how we trusted the code, we did change how we evaluated the code. And this AWS Security Agent now gives our customer builders some of the same capabilities that we've had inside the cloud for a couple of years now, so that your AI agent can both plan and execute your pen test for you. It can look at your source code, it can generate fuzz testing patterns, it can try to do code coverage, it can do, again, things that a human used to be able to do by hand, but not at this scale. And it turns out that it also does a better job because we are using the human creativity that used to be sort of spent doing the pen tests, we can use to invent new automated pen tests. And so we are now getting better results than a purely human team could do, even if they could keep up with the scale, which they can't. Now, I mentioned looking at the source code, but this agent can also look at your documentation, your API specifications, whatever is your infrastructure as code. In other words, how the cloud as a distributed system will be programmed to accept your workload and execute your code at the right time in the right way. All of that is context to this agent so that it can answer questions like, is it doing everything that we say that it should do? Or is it also doing other things that we didn't say? We'd like it to match. We would like it to be that what we say is what we do. And that in turn gives the customer the confidence interval they need in order to trust the new logic for their customers. So it turns out to be all about trust all the way down. So we don't have a huge amount more time, so I'm going to skip a little bit of this, except to say, I told you we encrypt the data that we get from our virtual servers, from cloud instances, and we encrypt that end to end. So if it's going from one part of our network somewhere on this world map to some other place that is on our network, then it will be encrypted with that end-to-end key until it gets to the far end. If, on the other hand, it's going to leave our network, and a lot of traffic must leave our network because we have the services on our network, but often the users who are accessing those services are not on our network, right? They have their own ISP. So in that case, we have to decrypt the data at the edge of our network before we hand it on to the public network where it can make its way closer to the initiator, to the user, to the browser usually. But within our network, after we have encrypted it end-to-end in the way I just described, we encrypt it again hop by hop. Every time a packet enters a link, we are encrypting it with that link's current key. That link's current key is not recoverable from any of our equipment. There's no API for it. And it's a long-lived polymorphic key where each instance of the key depends on the previous one. So if the link has been up for 10 years, then the key has been rotating for 10 years. And the time that an adversary would have had to recover that key was 10 years ago. So what I'm trying to describe here is that we worry a lot about keeping our customer data secure. You know, it is our policy that customer data is stored only where the customer has allowed it to be, and it is available only to those parties that the customer has chosen to allow. Those are not choices we make, and by default, there is no operator access. If a customer does not give us permission to see something, we can't. In other words, if we have an automated alert in an AWS data center where we want to tell the customer, we think you are running a Bitcoin miner, which is against our acceptable use policies and probably indicates that you have had your password stolen by somebody who wants free compute so that they can mine Bitcoins. The way that we detect that is not by looking at what you are running on your VM instance. It's not by looking at the memory that instance is using. It's not by looking at the traffic that instance is generating and receiving, because we can't see those things. When we want to send that alert, we do it because you're using too much power in too few cores. That's what we can see, because we're providing you the CPUs. We know how much power you're drawing, and that's the limit of what your operator can witness. And that turns out to be, again, a way to earn trust. And, you know, I'm not going to say anything controversial about the European sovereign cloud. You know, we do have a cloud that is strictly European, only European citizens as employees. It's currently all located in the Berlin region of Germany, and there are people who want that. And so we built it. But I'm here to tell you, we already didn't have the ability to store data outside Europe without the customer's permission, or to let anyone see that data without the customer's permission. So we had already built what we thought was a strong enough system, and then we built a better one because some customers needed additional assurances. Oh, thank goodness you can't see the pop-ups. When you build a network, you have to have that thought in mind. If you take no other steps, then it's possible that your network will be transmitting things in clear text, which could be observed through a passive optical splitter, and would create various risks that you would want to manage. Our network has evolved considerably in the last 25 years, and this is where it sits today. If you come back next year, I think these numbers will be larger because the cloud will continue to grow. So I think this is interesting for only one real reason. So if you have an AWS Outpost on-prem, then some of your apps will be running on-prem. But because it's our operating system running on servers that we provided to you, in a complete rack. You will not be managing them through the console. You will not SSH to them. Indeed, you will use the AWS console, and one of the regions that it will offer you is your own on-prem outpost. And the reason this is germane to the conversation is that we will be encrypting everything that you try to transmit using end-to-end keys, even though you will already have encrypted it inside of your web server, so that your encryption is between you and the far-end browser. We're going to add additional encryption before that data leaves your premises. And that's, again, that's just how we think. At AWS, we say and we act that that security is our top priority. We used to say priority 0, but the wording has changed over the years. But the other thing to note is this thing called the rugged edge. Sometimes you just need a little bit of cloud in the middle of nowhere, and then you're going to bring it in with a truck, and you're going to bring it back out with a truck. And famously, right after the Ukraine war started in February of, I guess, 2022, we sent a couple of snowballs on a truck into the heart of Ukraine, and the government uploaded all of their sensitive data: who is a citizen, what property exists, who owns what property, all of that, which would have been a catastrophic loss had it had a bomb landed on it, or had the invasion succeeded. And then we put the snowballs back on a truck and took them back out to the rest of the world, where we then uploaded them into our cloud. There wasn't a way to do this without the truck. And yes, I'm sure you could have gotten it done with a station wagon full of mag tapes, but there was way too much data. It needed this density, and it needed this agility. So it was a proud moment for all of us. There's an error here. Kuiper is now called LEO. So we're putting up a low Earth orbit satellite network so that we can provide live connectivity in places that are far from fiber networks, and it's called LEO. And we have a couple thousand satellites up there already, and it's coming. I think that's cool. So let me get toward summarizing what I'm telling you here. You need to, in order to trust that a system is going to be both useful and safe, which are the things we want, we have to have some reason to trust what it says, and in that case you need the guardrails and the automated reasoning. You need to be able to trust that it's not being tampered with or witnessed, and that's where all of the encryption and the rules about where data can be stored and who can witness it and so on, and the operator access limitation by which I will never see your data, no matter what I try to do inside the company. You need resilience. You can't have downtime. It can't be that for a few minutes out of every month your system is not reachable by your customers. So we need multiple paths, and every one of those paths has to be both secure and massively over-provisioned. And finally, you need this autonomous security, because humans in the loop are not fast enough anymore to do security. So we need to invest human creativity in automation of security, automation of all of the fundamentals of trust. Because we want that trust to happen quickly, but not without having been earned. So I'm at the end of my time. I thank you all for joining me. I will be standing around outside if there are follow-up questions, because I don't think we're going to have time to answer them at the podium.